From the surface of our world, Earth feels vast. It stretches beyond the horizon in every direction, layered with continents, oceans, mountains, and skies that seem endless when measured by a human lifetime. You can cross countries, sail seas, climb peaks, and still feel that there is always more land ahead, more distance left unexplored. For most of our species' history, this sense of immensity defined reality itself. Earth was not just large, it was everything. From that ground-level perspective, our planet appears dominant and permanent. The oceans cover most of its surface, the continents span thousands of miles, and the atmosphere arches overhead like a protective shell. Early humans had no reason to imagine anything larger. The sky was a ceiling, not an opening. The lights above were decorations, not distant suns. The ground beneath their feet felt flat and infinite because, on a human scale, it effectively was. Even today, with modern knowledge, Earth still feels big. Its diameter is nearly 8,000 miles. To walk around its equator at a steady pace would take years without stopping. Its surface area is so large that visiting every square mile, even briefly, would consume a lifetime. Measured against human bodies, human travel, and human memory, Earth is enormous. It is large enough to contain every civilization that has ever existed, every war, every work of art, every quiet moment of ordinary life. But size is always relative. The feeling of Earth's immensity depends entirely on where you are standing. The moment perspective begins to shift, Earth starts to lose its dominance, not because it changes, but because the frame around it expands. When we step back even slightly, Earth stops being the stage and becomes an object on the stage. It becomes one shape among others, one presence among many. This change in perspective is subtle at first. Earth does not suddenly vanish. It simply begins to shrink in meaning. It goes from being the entire environment to being a thing within an environment. And once that transformation begins, it never stops. The farther outward you move, the more Earth's apparent importance dissolves. It does not collapse dramatically. It fades. It becomes smaller, quieter, less central, not because it loses value, but because scale itself is unforgiving. Scale does not care about life, history, or significance. It only measures size and distance. This journey is not about diminishing Earth emotionally. It is about seeing it clearly, about stripping away the illusion created by proximity. When something surrounds you, it feels infinite. Only distance reveals its true boundaries. As we move outward, Earth will continue to shrink, slowly at first, then rapidly. It will go from world to point, from point to speck, from speck to something that can no longer be resolved at all. And with each step back, the same question will echo more clearly. Not whether Earth matters, but how small it truly is. This is where the real journey begins, not with drama, not with spectacle, but with distance. The first true step away from Earth isn't to the edge of its atmosphere, or even to the height where the curve becomes obvious. The first step is to our nearest companion, an object close enough to feel familiar, yet far enough to expose how empty space really is. The moon hangs above us like a constant witness. It shapes our nights, moves our tides, and quietly anchors the rhythm of weeks and months. From the ground, it feels nearby, large enough to show texture, close enough to feel like it belongs to our world. But near in space is a strange word. The moon is, on average, almost 250,000 miles away. That number doesn't land in the mind easily, so translate it into something more revealing. The gap between Earth and the moon could fit a long chain of Earths laid end to end. not one or two, dozens. And still, there would be room. This is the first hint that the universe is not built like our intuition expects. On Earth, distance is usually filled with something: air, land, water, buildings, sound. In space, distance is often filled with almost nothing. The moon is our closest neighbor, and even here the separation is staggering compared to the size of the objects involved. And yet, despite that emptiness, the moon is not insignificant. It is unusually large compared to the planet it orbits. If you look across the solar system, many planets have moons that are tiny fragments, captured rocks, irregular debris. Our moon is different. It is massive enough that Earth and Moon feel less like a planet with a satellite, and more like a paired system in a shared dance. That pairing has consequences. The tides that pulse across our oceans, the slow breathing of coastlines, the hidden movement of water beneath ships and storms. Much of it is moon-written. Even Earth's stability is partially moon-made. Our planet's axial tilt, the angle that gives us seasons, is steadied by that gravitational companion. Without it, the tilt could wobble wildly over long stretches of time, pushing climate toward extremes that might have made complex life far more difficult. The moon is not just scenery, it's architecture. And still, in the context of scale, the moon is a small object. It's a little more than a quarter of Earth's diameter. If Earth were reduced to something you could hold, the moon would be noticeably smaller, but not absurdly so. What matters is not only the size difference, but the distance between them, and how much nothing lies inside that gap. Once you accept that emptiness as normal, the next comparison hits harder, because the next object is not a companion. It is the furnace that rules our existence. From Earth, the sun seems like a disk, bright enough to hurt your eyes, warm enough to shape the day, but still something that feels up there, like a lamp in the sky. That's the illusion of distance. In reality, the sun is so large that Earth begins to look less like a world and more like a grain. The sun's diameter is over 100 times Earth's. But diameter is the polite way to talk about scale. Volume is where the mind begins to slip. In volume, the sun is so immense that well over 1 million Earth-sized spheres could fit inside it. Imagine that. Not 1 million people, not 1 million cities, but 1 million entire worlds like ours. Every mountain, every ocean basin, every ecosystem, every memory of history, stacked into the space the sun occupies. And that still wouldn't fill it with anything but the idea of Earth. In mass, the imbalance is even more brutal. Nearly all the mass of the solar system belongs to the sun. The planets are ornaments by comparison, moving along paths determined mostly by that central gravity. Earth feels like the anchor of reality because we live on it. But the solar system's true anchor is the star we orbit. And the distance between us and it is its own kind of revelation. Roughly 93 million miles. Light, moving at the fastest speed the universe allows, still takes more than 8 minutes to cross that gap. This means the sunlight touching your skin is always slightly old. The warmth on your face is a message that left the sun minutes ago. Even the idea of now becomes strange when your world is governed by a star separated from you by a distance measured in light time. So here, already, Earth is shrinking, not physically, but psychologically. It is being pushed out of the center. We begin to see the solar system not as Earth and everything else, but as a star with a family of worlds, one of which happens to carry our life. And this is still the gentle part. Because even the sun, so enormous compared to Earth, is not a giant in the broader universe. It is a fairly ordinary star, one among countless others. Its power feels absolute, only because we are close enough to depend on it. From farther away, It would be one bright point among many, indistinguishable without careful measurement. And that is the next shift. The moment you realize that the star that defines your existence is not exceptional, not rare, not central, just local. We began with Earth feeling endless. Then we saw how quickly endless breaks when you step back. Now, as we move outward through the solar system, Earth will become something even smaller than a grain in the mind's eye. It will become a reference point you struggle to keep track of, because there will soon be distances so large that Earth's entire orbit becomes a detail. And once the solar system itself starts to shrink in the frame, the real disappearance begins. Beyond the Sun's immediate authority, the solar system stretches outward into regions where warmth fades and distance stops behaving intuitively. The inner worlds, rocky, compact, familiar in name, cling close to the star, confined to a relatively small zone. From the Sun's perspective, their orbits are tight loops, barely spreading outward before the scale begins to open dramatically. As you move past Mars, space does something unexpected. It doesn't gradually thin. It yawns. Between the inner planets and the giants lies a region often imagined as crowded and dangerous, but in reality defined by emptiness. The asteroid belt is not a swarm you would dodge through like debris in a movie. It is a vast, quiet volume where millions of objects drift so far apart that, if you passed through it, you might never notice a single one without instruments. Even here, where material failed to become a planet, space dominates matter by an overwhelming margin. Then you reach the giants, and scale shifts again. Jupiter is not just larger than Earth. It overwhelms comparison. Its diameter spans more than 10 Earths side by side, but that still understates the difference. In volume, Jupiter could absorb over 1,000 Earths and barely feel occupied. It is a world so massive that it reshapes the entire solar system's architecture. Comets bend toward it. Asteroids are redirected by it. Impacts that might have scarred the inner worlds are often intercepted by its gravity. Earth's long-term stability may owe more to this distant giant than to anything beneath our feet. And yet, for all its dominance, Jupiter is still a planet. It still orbits. It still obeys. Saturn follows, lighter in density, but still immense, surrounded by structures so wide and thin they challenge intuition. Its rings span distances that dwarf Earth's diameter, yet their thickness would vanish if scaled to anything familiar. Uranus and Neptune extend the system farther still, worlds where sunlight is weak, and years stretch longer than entire chapters of human history. By the time you reach Neptune, Earth's orbit has already become insignificant. It is no longer a path you can meaningfully track. It's a detail lost near the center of a system that now spans billions of miles. And still, the solar system is not finished. Beyond the planets lies another shift in perspective. A region of icy remnants stretches outward, populated by frozen bodies left over from formation. Farther still, a distant halo surrounds everything, a vast spherical domain so far removed that objects there barely feel the sun's pull. This is not an edge you can see. It is an edge inferred through motion, through rare visitors that fall inward from darkness. At this point, the solar system is no longer something you can picture as a diagram. It becomes a volume so large that even light takes days, then weeks, then months to cross meaningful portions of it. The sun, once overwhelming, is now a bright center surrounded by an ocean of nothing. And Earth? Earth is gone. Not metaphorically, literally gone from perception. At this scale, Earth's size is irrelevant. Its orbit cannot be resolved. Its existence must be remembered, not seen. The solar system is now the object, and Earth is merely one untraceable point deep inside it. This is the moment where something fundamental breaks in the human sense of importance. Because the solar system, which already erased Earth from view, is itself about to face the same fate. The nearest star is not just far. It is so far that our entire solar system shrinks to something smaller than a point of light from that distance. The gap between stars is not filled with systems brushing against one another. It is filled with silence, measured in light years. And once you step into that interstellar gulf, the solar system becomes what Earth already was: a memory, a concept, a location you must describe rather than observe. The disappearance has begun in earnest. The space between stars is not an extension of the space between planets. It is something fundamentally different. When you leave the outermost influence of the Sun, you don't enter a slightly emptier neighborhood. You enter a gulf so large that the solar system itself collapses into insignificance. The nearest star is not close in any human sense of the word. It is separated from us by a distance so vast that even light, the fastest thing that exists, takes more than 4 years to cross it. To grasp what that means, remember that light takes just over 8 minutes to reach Earth from the Sun. Multiply that delay by hundreds of thousands. That is the scale of separation between stars. From this distance, the Sun is no longer a source of warmth or structure. It is just another star, slightly brighter than average, only because it happens to be nearby. And the solar system that once felt immense is now compressed into something smaller than a single pixel of meaning. The planets, the Kuiper Belt, even the farthest icy remnants blur together into one unresolved point. Earth does not merely disappear here. It ceases to be a useful concept. If you were positioned near the nearest star and looked back toward our system, you would not see a planet. You would not see an orbit. You might barely detect the Sun at all without instruments. Earth would be lost entirely inside that glare. Too small, too close, too dim to isolate. This is where intuition finally fails completely. Because stars themselves, which feel like anchors of the cosmos from Earth, now begin to multiply. One becomes many. The sky fills with points of light that are not decorations, but distant furnaces scattered across enormous voids. Each of those points is a sun. Many are larger than ours, many smaller, many older, many younger, many already dead in ways that light has not yet told us. And the distances between them remain vast. Stars are not packed tightly, even inside a galaxy. If the Sun were the size of a grain of sand, the nearest star would still be several kilometers away. Most of space is not occupied by objects. It is occupied by separation. As more stars come into view, they begin to organize. Patterns emerge. Not because the universe prefers symmetry, but because gravity leaves fingerprints. These stars belong to a structure larger than any system, a galaxy. From within it, a galaxy feels like everything. From outside, it is just another object. Our galaxy contains hundreds of billions of stars, arranged into a flattened disk with sweeping arms. From Earth, we see it as a faint band across the sky, unaware for most of history that this pale glow was not mist or myth, but the combined light of countless distant suns. When you step far enough back to see the galaxy as a whole, something striking happens. The solar system is gone. The Sun is gone. Earth is not even an afterthought. The galaxy is now the unit of scale, a vast rotating system tens of thousands of light years across. And within it, stars orbit a center they will never reach, bound by gravity and time. Our Sun is just one of them, located far from the core, in a quiet region with no special distinction. At this scale, Earth's entire history, every civilization, every species, every moment of consciousness exists within a structure so large that no comparison holds. If the galaxy were reduced to the size of a large city, Earth would be smaller than anything that could be physically represented. Not a building, not a grain of sand, not even a molecule. It would be smaller than the idea of size itself. And yet, even now, this is not the end of the shrinking. Because the galaxy is not alone. It is one member of a group, one luminous island among many, drifting through a larger darkness. Other galaxies surround it, each containing their own hundreds of billions of stars, their own planets, their own possibilities. Some are larger, some smaller, some close enough to influence each other across time. As these galaxies gather into clusters and clusters into even larger structures, the scale expands again. And again, Earth does what it has done at every step so far. It vanishes. Galaxies do not drift alone. Gravity gathers them the same way it gathers stars and planets, pulling luminous islands into loose communities that span millions of light years. From a great enough distance, a single galaxy no longer feels dominant. It becomes one point among many, each with its own internal complexity, each carrying hundreds of billions of stars, yet collectively forming something even larger. Our galaxy belongs to such a family. Dozens of galaxies move together through space, bound by gravity into a shared structure. Some are large spirals like ours. Many are dwarfs, faint, irregular systems with only a few million stars. They orbit, interact, and slowly change one another over billions of years. Collisions are rare in the human sense, but inevitable on cosmic timescales. When they happen, they do not look like crashes. They look like slow interpenetrations, stellar systems passing through each other, while gravity quietly reshapes their futures. As you step farther back, even this group loses its individuality. It becomes part of a much larger concentration, a cluster of galaxies containing hundreds or even thousands of members. Here, gravity dominates on a scale that defies everyday logic. Entire galaxies orbit a shared center of mass. Hot gas fills the space between them, glowing faintly in wavelengths the human eye cannot see. Dark matter, invisible but massive, forms the scaffolding that holds everything together. At this scale, galaxies are no longer the main characters. They are components. The distance between them is still immense, yet compared to the scale of the structure itself, that separation begins to feel small. Patterns emerge. Filaments of galaxies stretch across space like luminous threads, converging at dense nodes where clusters reside. And this is where perspective takes a decisive turn. Clusters themselves are not isolated. They connect to other clusters through enormous chains of matter, forming superclusters, structures so vast that light requires tens or hundreds of millions of years to cross them. These are among the largest coherent features in the universe. They are not bound tightly like planets or stars, but they are not random either. They are shaped by the universe's earliest moments, by tiny fluctuations in density that gravity amplified over billions of years. From here, Earth is not small. Earth is irrelevant to scale. Not because it lacks meaning, but because it no longer participates in the measurement. The planet is so far beneath the threshold of visibility that it cannot be compared. The solar system vanished long ago. The sun disappeared earlier still. Even the galaxy now feels like a detail, a single spark embedded in a structure that stretches across unimaginable distances. Step back one final time, and the pattern resolves into something both beautiful and unsettling. The universe is not evenly filled. Matter gathers along vast filaments, forming a cosmic web that spans the observable universe. Between these filaments lie enormous voids, regions so empty that hundreds of millions of light years can pass without encountering a single galaxy. Most of the universe's volume exists in these voids, not filled with stars, not filled with planets, filled with absence. The filaments glow with galaxies like frost along branches, outlining a structure that looks almost organic, as if the universe itself has a skeleton. And this skeleton is immense beyond language. Individual superclusters are no longer the largest things that exist. They are simply knots in a much greater tapestry. At this level, size itself becomes abstract. Distances are no longer measured in miles or even light years, but in fractions of the observable universe. Objects are described not by what they contain, but by how they distort the distribution of everything else. And Earth? Earth is gone in a way that cannot be reversed by imagination. It is not just unseen, it is unlocatable without deliberate calculation. It exists only as a remembered coordinate in a system that no longer cares about coordinates. Yet this is not the end of the journey. Because even this immense web, this vast architecture of matter and emptiness, is only what we can see. It is bounded not by walls, but by time, by the finite age of the universe and the finite speed of light. Beyond that boundary lies more universe, perhaps vastly more, perhaps infinitely more. And against that backdrop, Earth's true scale finally becomes clear. There is a boundary to what we can see, but it is not a wall. It is not an edge you could approach or cross. It is a horizon created by time itself. The universe has not existed forever. It has a finite age. And because light travels at a finite speed, there is a limit to how far information has been able to reach us since the beginning of cosmic time. That limit defines what we call the observable universe. Everything within this vast sphere is visible in principle. Everything beyond it may exist, but its light has not yet had time to arrive. We do not see the universe as it is now. We see it as it was, layered across time. The farther away something is, the older the light we receive from it. When we look at distant galaxies, we are looking into the past. Millions of years, billions of years. We are seeing objects not as they are, but as they once were. Some of the galaxies we observe no longer exist in the form we see. They have collided, merged, changed, or disappeared entirely while their light was still on its way to us. The observable universe is not measured by how far you could travel. It is measured by how far time has allowed light to travel since the universe began. And because space itself has been expanding the entire time, that distance is far larger than intuition suggests. The universe is about 13.8 billion years old. But the observable universe is not 13.8 billion light-years across. It is far larger. Space has stretched while light was in transit, carrying galaxies away from one another as the light moved through it. The result is a visible universe nearly 93 billion light-years in diameter. 93 billion light-years. That number is not just large. It is functionally beyond comprehension. Light, moving at the ultimate speed limit of reality, would need 93 billion years to cross it today. Not days, not centuries, tens of billions of years. Within this volume exist an estimated 2 trillion galaxies. Each galaxy contains anywhere from millions to trillions of stars. The total number of stars in the observable universe is so large that it resists language. Hundreds of billions of trillions, more stars than grains of sand on all the beaches of Earth, multiplied beyond meaningful comparison. And Earth exists inside this, not at the center, not in a privileged location, not in a special region of space. Earth occupies no cosmically favored position at all. It sits in one galaxy, among trillions, inside a filament of matter that is itself one strand in a vast web. At this scale, Earth does not shrink further. It disappears entirely. There is no analogy that survives here. no metaphor that holds. If the observable universe were reduced to the size of Earth itself, our planet would be smaller than the smallest physical scale we know how to describe. Smaller than atoms, smaller than subatomic particles, smaller than anything that could be assigned a size without breaking the meaning of the word. Earth is not a dot. It is not dust. It is not a grain. It is absence in the mathematics of scale. And yet, against all odds, something extraordinary has happened on this vanishingly small world. Matter organized itself into life. Life evolved into complexity. Complexity produced awareness, and awareness became capable of understanding the universe that dwarfs it. From a planet that cannot be represented at cosmic scale, the universe has been measured, mapped, and questioned. This is the deepest paradox of existence. The universe is vast beyond comprehension, yet comprehension exists within it. The cosmos is overwhelmingly empty and hostile to life, yet life has emerged. The scale of reality erases Earth completely, yet Earth contains minds capable of grasping that erasure. From this perspective, smallness does not mean insignificance. It means rarity. Earth is not important because of its size. It is important because of what happened here. Because, as far as we know, this is the only place where the universe has produced observers who can ask what the universe is. There may be others. There may be countless civilizations scattered across galaxies we can never reach. But until evidence tells us otherwise, Earth is the only confirmed point where the universe is aware of itself. And that makes this tiny, unmeasurable world more remarkable than any supercluster, any filament, any cosmic void. Because without observers, the universe is just matter and energy following rules in silence. On Earth, the universe learned to look back at itself. This is where the journey ends. Not with Earth restored to importance by size, but with Earth revealed as something far stranger. Infinitesimal in scale, immeasurable in meaning, and suspended, improbably, within a cosmos so large that it almost does not matter that anything exists at all.